In this video, I'm going to be talking about Newton's second law. What is it and how is it used? Newton's second law is basically F net equals mass times acceleration and all the relationships involved within that formula, which are the net force is directly proportional to the acceleration, and then also the mass is inversely proportional to the acceleration. So to fully understand the formula, you want to make sure you definitely know what net force is. It means the total force that's acting on an object. So although there might be multiple things pushing or pulling on it, the net force is the final number representing how much unbalanced force is pushing or pulling on it. For example, if you have a box over here with 5 newtons pulling to the right, and you maybe have 2 newtons of force opposing that 5 newtons, then you would say that your net force is 3 newtons to the right. All right, so let's go ahead and take a look at some of those relationships that were mentioned in this box over here. So the first one is we have 2 of these scenarios here where the force being applied to the right is 100 newtons for both of them. So the force is staying constant, but the mass of our box is changing from 10 grams to 20 grams. So we have 2 times the mass. Now, earlier we said that mass is inversely proportional to acceleration. So that means that if the mass goes up, the acceleration must go down. And it is an inverse relationship, which means that if you have 2 times the mass, if you take the inverse of 2, that is 1/2, you have exactly 1/2 the acceleration. In the other relationship that's shown below right here is that force is directly proportional to the acceleration, the first one we mentioned over here. So in this case, we have a constant mass of 20 kilograms for both of our objects, but we have a force of 10 newtons that is cranked up to a force of 30 newtons, which means that if we have 3 times the force, that means that as the force goes up, the acceleration also rises directly. And if we have 3 times the force, then we also have 3 times the acceleration. Now, my last example is more of like a real world example. So we have 2 different football players here. Looks like we have maybe a wide receiver and a lineman in all kinds of different sports. You're going to notice that depending on the type of sport or the type of position being played in a sport, the athlete has a particular build. If it's someone who has to accelerate very frequently, they have to speed up, they have to slow down, they have to change direction, they're going to tend to keep their mass down so that they're able to increase their acceleration a little bit more easily. So all these athletes are going to build up their muscle so they are able to apply lots of force. In some cases, some of these athletes even apply 5 times their body weight of force into the ground to make themselves accelerate very, very quickly. And in this case over here, where a lineman does have to accelerate, it might be more important for him to have more mass. And these linemen who have more mass tend to not accelerate quite as much. Okay? They do need some acceleration, but they don't need quite the amount of acceleration as someone like a wide receiver that may need to speed up, slow down, and change direction very frequently. So there's a lot of different applications that you could use this with. You can use it with cars, you can use it with athletes, you can use it in simple situations as we stated before. But Newton's second law is basically the application of this formula, net force equals mass times acceleration, and using both of these relationships within it to solve for different scenarios. I hope that was helpful in helping you understand Newton's second law. Thank you for watching and listening.